All right, so today we're going to take a look at section 10.3, and we're going to move on with our ways of counting things. And we're going to look at two different kinds of ways of counting. One is permutations, and the other is combinations. All right, so the first one we're going to take a look at is permutations. Permutations is a way of counting when order matters. So that's the key down here, is that order matters. And what this is, it's the number of arrangements of n things taken r at a time. Okay? When the order matters. Now, there is a formula for how to process this kind of a number. And the way that that formula... All right, give it a sec. The way that formula looks is it looks like this little n and this little r are subscripts, one in front of and the other one after the letter capital P. Okay, that's the notation for it. Some books will use other notations. This is the one your book is using, so we're going to use what they've got. And the formula for doing that is that you have n, which we talked about last time, of how that looks, over n minus r factorial. And in fact, you may look at that and say, that looks almost like something I did last time. We did an example like that where we were given the letter n and we were given the number for n and we were given the number for r and we plugged them in. And this is where this is coming from, this and the other formula we're going to have in a little bit. So this is the way of calculating n things taken r at a time. So I want to show you the other one, and then we're going to look at how to calculate the actual values, and then I'm going to show you the context behind each one. Okay, so that's the way we're going to head today. The other one is a combination. Okay, I didn't even touch it, and it just went away. A combination is still n things taken r at a time, but the difference, the primary difference between the two is that the order does not matter when you have a combination. Order does not matter. So whenever you're looking at any of these particular problems, that's the question to ask yourself, is does it matter what order this happens in? Or does it not matter? So some things that you might be thinking of, for instance, like if you were making a sandwich, does it matter what order all of the condiments go in on the sandwich? No, probably not. I mean, right? This doesn't really matter. It's going to taste the same whether I put the mayonnaise on first or the cheese on first. Doesn't make any difference. Might be easier to put the mayonnaise on the bread than on the cheese, but it doesn't make any difference on how it tastes, right? However, there are some things where the order does matter. It would matter whether or not you put your pants on before your underwear. Just saying, right? The order in which you get dressed, at least some of it matters. And we could do the shirt instead of the pants, but there's some of it that matters. So there are different things that we do in our days that the order does and doesn't matter for, and that's what you're going to be taking a look at when you look at these particular problems. Now this one's formula looks similar. You've got an N and then a capital C, or it looks like an uppercase, and then an R. The N and the R look like subscripts. The difference is that the N factorial on top here, that's the same, and you have an N minus R factorial on bottom, but you have an additional on bottom R factorial. So you've got this additional piece on the bottom that you didn't have before. Okay, and that's actually the formula that we used last time with one of the ones we in particular did. All right, so let's take a look at actually working through some of these in terms of their formula, and it'll feel a lot like what we did last time. Now, it doesn't look like what we did last time because I've got some notation that I didn't have before. I've got a 12, I've got this large P, and then I've got a 3 after it. But you're just going to use those particular formulas, so make sure you're looking at the right one. This is a P, so it's a permutation. It's the first formula that we looked at just a minute ago. And so for the first formula, what went on top? n factorial. And which one of these numbers is n? 12. And as a general rule of thumb, it's always going to be the larger one. I mean, so you don't really have to even really care which location things are in. N's the largest value that's there. If they match, then it's still the largest value because they're the same. But we've got 12 factorial then on top. And then on bottom, what is on bottom for a permutation? This will be 9 because it's just... Okay, so it's 12 minus 3 factorial. And then just like Ethan said, that is 9 factorial. So I have 12 factorial on top, and I have 9 factorial on bottom. So far, so good? Now, one of the things we talked about last time is that you can't reduce that 12 and that 9 right now, right? The only reducing that you can do with factorials is if they exactly have the same number with the factorial after it. So what's the best I can do?
Write it out to 12 times 11 times 10 times 9.
Thank you, Garrett. 12 times 11 times 10 times, and I'd like to stop at 9 factorial. Would that be okay with you? We talked about that last time, right? And why would I like to stop at 9 factorial? Yeah, because I have a 9 factorial in the denominator. And so if I were to write out the 9, 8, 7, 6, 5, 4, 3, 2, 1, I'd write it on top and on bottom, and all that 9 down would cancel. So once I get them to be identical in their factorial notation on top and on bottom, I can reduce them. So you grab your calculator that is not a phone, and I want you to multiply 12 times 11 times 10, and what do you get? Ethan already had it, 1320. Okay, is everybody all right with that one? All right, 2 is very similar, right? I've got a 12 and I've got a 3 in it, just like before. And in fact, for combinations, the formula has the same value on top. What will go on top here? 12 factorial. What's the difference, though, in this formula compared to the other one? I've got an extra factorial in the denominator, don't I? I still have that same 9 factorial, agreed? But I've got the r factorial that Alyssa said. And what is my r in this problem? It's 3. So this is 3 factorial, and then I'm going to write it in just for a moment so we can see that it matches the formula, the 12 minus 3, but that, of course, is 9. So this is 12 factorial over 3 factorial, 9 factorial. All right, very good. I can do the same thing, right? I can write my 12 out till I get to 9. What else do I need to do? I need to do 3 factorial, or I can write out what 3 factorial is. What would 3 factorial be written out as? 3 times 2 times 1. And you could multiply that if you'd like, or you can take a look for reducing options. So this is the 9 factorial. It cancels. What else cancels? The 3 with what? Okay. How about the 3 and the 2 with 12? Could I do both of them?
Do the whole bar.
You could also get the 10 reduced.
You could. So you can reduce a lot of different things. And we mentioned that last time, too, that there's not one unique way to do this, right? So you could, so I'm going to do it what you suggested. I'll cancel because you guys noticed it first. So I cancel the 3 with the 12, and what does that leave me on top? 4. A 4. And then you could either cancel that 4 with the 2, or you could cancel the 2 with the 10, and you're going to get the same thing. If I cancel the 2 with the 10, I have a 5 here. Okay. Again, it doesn't matter. You're going to have the same values on top once you multiply them. And what do you get when you multiply 4 times 11 times 5? 220. Now notice, comparing these two solutions, which one's larger? The first one, the permutation one, right? And because they're the same numbers, they both had 12 and 3, agreed? And the permutation was larger. What did we say back at the descriptions was the difference, the main difference between permutations and combinations? That's the formula difference. I mean conceptual difference. Whether the order matters or not. So which one did the order matter on? The first one, permutations. So when the order matters, I'm going to get more options of how something can happen, right? Does that make sense? I mean, if I only have 2 things to do and it doesn't matter what order I do them in, there's only one way to do something. But if I have two things to do and I can do one and then the other and I'm counting the number of different ways something can happen, I get more choices. I have more options. So I will always have more in a permutation count than in a combination count. Okay? All right, so I want to take a look with you at some examples of making decisions on whether or not the order matters. So we're going to do a few different examples. The first one we're going to do is a contractor problem. So Jeff Hubbard's a contractor, and he builds homes of 8 different models. He presently has 5 lots to build on. Okay, so do you ever have a picture in mind? He has 5 different locations. We don't know if they're right in a row or if they're in different parts of the city or state or something like that, but he has 5 different plots of land. And then it said he has 8 different models. That's like saying he has 8 blueprint options he has. Okay, everybody with me so far? All right. It says, in how many ways can he arrange the homes on these lots so that 5 different models will be built? So the first thing you have to decide is, does the order matter? Are you sure? Why do you think maybe it would?
Because you have to have 5 different ones. It's kind of restricted.
You could have 5 different ones from choosing among the 8 and the order not matter. But what is it that makes the order matter here? It does matter. Have any of you ever watched HGTV when they go out and look for houses? Evidently, I'm the only one. Oh man! All right, so a little bit of information for you here. First of all, do you want to live right by the highway? Maybe not. Maybe if you commute, you would. Correct? Do you want to live way far in the middle of town, right next to the school? Maybe if you have kids and you want them to walk to school. So would it matter to you if the house were built on the highway versus built in the middle of the school district? Would it make a difference? Could it make a difference? Yeah. That's why the order matters. He's going to pick 5 of these properties and he's going to put them somewhere. All right? But it potentially matters where he puts them. Does that make sense? If you've ever heard the statement like location, 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 that's the biggest thing, is it matters where the location is of where you buy your property. It matters. I'll tell you what, I don't want to buy a property next to somebody whose house is always a dump. Right? In fact, I get grumpy when the person next door to me doesn't mow his grass. Okay, the location matters. Even if, because we don't know for sure, but even if all these houses were in a row, if one of them, for instance, was on the end and one of them was in the middle of the cul-de-sac, it could still matter. Right? I've seen people on HGTV get real picky about the fact that it's an end lot. Really? This is not something that would matter to me, but it matters to some people. So we have the potential here that the order where these lots are does in fact matter, because it could change whether or not someone wants that property. Does everybody make sense with that? Garrett, no?
No, because I don't see how order and location are common.
Okay, so he has to pick 5 houses. He has to pick 5 blueprints. Let me say it that way. He has to pick 5 blueprints, but he has to make the decision on which of those blueprints goes on which lot. It matters whether he puts the 3,000 square foot home by the highway or the 3,000 square foot home on the little 12 by 12 lot over here. He has to make that decision. That's where his ordering comes into play. He has to make a decision about where that property gets built, where that blueprint gets built. I know, but it does say that he has 5 lots to build on. That's where the ordering's coming into play. He has to decide. I mean, what's he going to do, just draw it out of a hat and stick a house on a piece of property? Probably not. It probably matters what's built around it, doesn't it? You guys have seen these different homes being built, and occasionally something will look really out of place. They'll have some gigantic house in the middle of some dumpy little neighborhood, and do you think that was a good decision? Probably not. I mean, he has to decide. One way or another, he has to decide. It will make a difference how much money he makes on the property, where he puts it. That's the decision. It's the lots of where he's building on them. Hey, Colt, can you put that away for me, please? All right. Is that better? Because if you say order doesn't matter, what you're saying is that it doesn't matter which house goes on which property. That's what you're saying. If order doesn't matter, then it doesn't matter which house goes on which piece of land in this context. We'll get to another context. Maybe it'll help. Okay, so order matters. I think we got to move on this one. Order matters because he has to make a decision about which blueprint goes on which property, which location. Okay? All right, so if order matters, which one is it? Is it a combination or a permutation? It is a combination or a permutation? A permutation. When order matters, it is a permutation. So we've got this capital P. What goes before it? N, which is, in this problem, what is it? Did you say it, Garrett? It is. It's 8. It's how many things we're choosing from. He's choosing from 8 different blueprints. Okay, so that's how many we're choosing from. And then the value that comes after it would be the number 5. It's how many we're picking. So he's picking 5 blueprints, and he's deciding where those houses are going to be based on the blueprint, which blueprint he picks and which location he puts it on. All right. Now you're back to doing what we did on the last 2 slides, last slide where we did the 2 problems of the formula. So what goes on top? 8 factorial, right? What goes on bottom? Yeah, it's 8 minus 5 factorial, which is 3 factorial. So I have 8 factorial on top, 3 factorial on bottom. So I'm going to write out my 8 down to 3, right? 8, 7, 6, 5, 4. And when I get to 3 factorial, I can stop because it'll match. All right. Grab your calculator and multiply 8 times 7. 67. 20. And just like in the last section, we're counting the number of ways something can happen. There's 6,720 different permutations, different ways that he could organize the house and pair it up with the right blueprint that goes on it. Okay? All right, let's try this one and decide if order matters. Julie needs to take 10 electives to fulfill her hours in her degree. That'd be a lot of electives. She's going to take 10. And she decides to start her career with electives because she doesn't know what she wants to major in. None of you are like that, are you? A few. It's okay. So she decides to take some electives to fill in some slots. If no courses have prerequisites, so it's not like this problem up here where you guys were asking questions about, no prerequisites. And there are 17 courses that she's interested in taking. How many different selections of the 10 electives can she make? Okay, so does the order matter? No. For a couple reasons that it says that the order wouldn't matter. Can you tell me one of them?
No prerequisites.
The no prerequisites helps you with that. Doesn't matter what the order is for the prereq issue. What else? It actually just asks how many different selections can she make. We're not trying to fit them into a semester, right? Fall versus spring or something like that. That would indicate that there's some sort of an ordering at that point that would be going on too. So this one, order does not matter. So which one are we using, a combination or a permutation? That'll be a combination. All right, how many items do we have to choose from? What goes in front of my seat? Somebody's saying 17, right? And how many will she choose? 10. By the time she's done, she will have chosen 10. All right, so the formula says, what do I put where? What goes on top? 17 factorial, good. What goes on bottom? Good. The 10 factorial is one piece. What else goes on bottom? 17 minus 10, which would be the 7 factorial. I'll go ahead and write it out this time since we've seen it a few times now. Notice the denominator has a 10 and a 7 in it, and 10 plus 7 is 17, just like the numerator. That always happens when you're looking at combinations, right? The two values on the bottom always add to what's on top. All right, so I have a choice on what I write this 17 down to. Where would you like to stop? I would like to stop at 10 as well, so that sounds good. 17, 16, 15, 14, 13, 12, 11, and 10 factorial. I'm going to put the 10 factorial at the back just so that I have more space in front. And then we have 7, 6, 5, 4, 3, 2, and 1. All right, so the 10 factorials cancel first. Wow. Why is it blue? Can you guys still read it?
It's been like that for a while.
It hurts my eyes.
I'm really sorry. It's not blue on my screen. I have no idea how to fix that issue. But I think I need to stick with white or you're not going to be able to see my marks apparently that I did in yellow. Today's a good technology day, isn't it? What's that? Think I should wiggle something? Here, you know what? Let's do this. Very good idea, thank you. I'd like to use the colors. You guys know I like colors. Let's try this. I was trying to be so still, and I still messed it up. Okay, 10 factorials, they canceled. That looks better. All right, what do you want to cancel? We've got lots of options now, so somebody give me a choice. Okay, 12. How about 12 and 2 and 6? Can I do that? Is that okay? So the 12 is the same as 2 times 6, so I can cancel all 3 of those. Now what? All right, that sounds good. 5 times 3 is 15, so I can cancel it with the 15. Now what? All right, 7 and 14, and the 14 would become a 2. Good. What else? 4 and 16 sounds good, and the 16 becomes a 4. All right, so this is the part you need to show. After that, it's up to you. Just don't lose any of these guys. These are all the ones that I've currently still have. I'm going to list them again just to make sure everybody can see them okay. I've got 17, 4, 2, 13, and 11. They're all multiplied. All right. Has somebody already done it for me? Maybe. Ooh, I heard 2 people. 19,448. She just thought she didn't have a choice to make, did she? She has 19,448 different things different ways she could choose these courses. That's kind of crazy, isn't it? Yeah. All right, so there's 19 different selections she could make. All right, let's take a look at another one. This problem is going to be set up, and we're going to talk about it a little bit before we move on into it all the way, but all of the last parts of the problem are all based on this particular setup. All right, so has anybody ever played cards in a very holy way? You know, friends in your living room, not at a casino. I'm talking about legitimate ways you're supposed to play cards. Have we? Okay. Well, we're going to run through this. So those of you who have played are going to help me. And if you haven't, or you haven't played in a while, or you don't know details, make sure and write some of this down. Okay? So the first question is, how many cards are there in a standard deck? There are 52 cards in a deck. Okay, that's important. What colors can your cards be? There's 2 different colors. We'll get to the 4 in a minute. There's 2 different colors, red or black. Okay? And how many then are red? 26 are red. Good. How many are black? The other 26. Good. How many suits are there? There are 4 suits. What are they?
Hearts, spades, diamonds, clubs.
Good. Hearts and diamonds are red. And then the clubs and the spades are black. Okay. How many cards are there of each suit? There are 13. So there are 13 spades, 13 diamonds, 13 clubs, and 13 hearts. What's on the cards? What are the cards labeled besides their color and things like that? What can you have? If you pull out a card, you have a number. Okay, what numbers are there? 2 through 9. 2 through 10, actually, right? We have a 10 as well. All right, so we have 2, 3, 4, 5, 6, 7, 8, 9, and 10. You have 9 different number cards, 2 through 10. What do you have besides number cards?
Ace.
You have an ace? We have a king? Queen? Okay, we're not going to have jokers. We're throwing our jokers out. And jack would be the other one. Yeah. Okay, so how many cards are there that are 10s? There are 4. How many cards are there kings? 4. There's one of each suit, right? So there's a king of hearts, a king of diamonds, a king of spades, and a king of clubs. Okay. I think that's all the details we need to be able to keep working with our problem. So we're going to take a go at the next part. You ready? You don't act like you're so ready. All right, we're going to give it a try. All right, so the first thing is we're going to pass out 5 cards to somebody. And the question's first asking, consider a 5-card poker hand. That is, you've got 5 cards. Find out how many hands you have. Not hands like me. Hands, like a card hand. Not hands like this either. We're not going to count these 2 hands. But different hands of poker, how many different 5-card collections could you have when somebody gives them to you? First question, does the order matter? No. Okay, so imagine you're playing any card game you want. We can talk about Uno, Slapjack, War, I don't care, Old Maid. Pick whatever card game you want. What's the first thing you do when somebody hands you your cards? You usually rearrange them. You shuffle them in some way that makes sense based on the game, right? Maybe you do something with the color. Maybe you do something with the number order. Maybe you put things together in a certain way. So the order doesn't matter because the first thing you're going to do is rearrange them anyway. Okay, so the order does not matter. And since the order does not matter, what am I going to be using? Combinations. And I'm going to be using combinations on the entire problem here because I'm talking about this hand of cards, any kinds of hand of cards, okay? All right, so if I'm talking about this hand of cards and I'm the dealer and I'm giving you your 5 cards, how many cards are in my hand to give you? 52. And how many? Yes, so 52, and I'm going to give you 5. So there are 52 cards in my hand, and I'm going to give you 5 of them as the dealer. That's what I'm going to do. All right, so what's my numerator going to be? 52 factorial. What's my denominator?
5 factorial.
Good, thank you, Garrett. 5 factorial, 47 factorial. Right, because the 5 and the 47 add to the 52. This is where we came to last time when I told you, if you could, I think if you put 52 factorial in your calculator, for those of you who have the calculators with the factorial buttons, I don't think your calculator is going to like you very much. 52 factorial is a very, very large number, and it will probably tell you something like overflow, which means that even if you like that button, you can't use it here. So you've got to reduce, whether you like it or not. So you're going to write 52 out till you get to what? 5? No, 47. So 52 times 51 times 50 times 49 times 48 times 47 factorial. Do not forget the factorial at the end. It's still there. And you have the same factorial, except 47 factorial in the denominator. What else do you have in the denominator? 5 times 4 times 3 times 2 times 1. All right, so I'll start with the 47 factorial, then you're going to tell me what you want me to cancel. What would you like? Well, you've got all kinds of options. 5 and 50 sounds good. 5 and then 50, and the 50 becomes a, all right, 10. Now what?
4 and 52.
Okay, 4 and 52. What is the 40? 13. Good. Now what?
51 and 3.
The 51 and the 3. You guys are picking some challenging ones. What's 51 divided by 3?
17.
That one's 17. Good. All right, you got the easiest one left, 2. 2 and what? 2 and 50, or I'm sorry, 2 and 10 or 2 and 48. I heard Alyssa first, so we'll do 2 and 48. What's the 48 become? 24. All right, so if you chose something different, still okay. You're just going to have a different display until you multiply. So right now I have 13 times 17 times 10 times 49 times 24, I think. How many different 5-card hands are there?
598,960.
That's right. These are 5-card hands of cards, but there are 2,598,960 hands of cards that you could have. That's a lot, isn't it? That's a lot. So let's put some restrictions on things and see what happens. So let's say, for instance, now that you wanted a hand that was all red. Now that would be strange in poker. That doesn't get you anywhere, except that it probably made you think that you had something you really didn't have because you thought they were all diamonds or something. But let's say you wanted to know what would happen if I wanted all red cards. How would this problem be different than the problem before? Say for me, Larry. It's not half. Okay. Let's first decide then, is it a combination or permutation?
Combination.
It's a combination. The order still doesn't matter. How many cards am I giving you?
52.
No, not giving you 52. I'm still giving you 5 cards. That's my card. My hand of cards itself is 5 cards. But I want, say that louder for me, Tyler. There are 26 cards to pick from. So the part that's halved is not the answer. The part that's halved is how many I'm choosing from, right? I only have 26 cards that I want in my hand if I want them to all be red. So I'm going to figure out how many cards I can get, how many hands of cards I can have that are all red. I have 26 red cards. All right. So you might think, well, all I did was half something. It doesn't seem like that should be that big of a deal. Let's just see how big of a deal it is. So I have 26 factorial on top. What's on bottom? Good. 5 factorial, 21 factorial. All right, so I'm going to write my 26 out till I get to 21. And I've got that same 21 factorial in the denominator. And then I'm going to write my 5 down just like I did before. All right, 21 factorial went away. Now what? Somebody tell me a reducing step you want me to do. 5 and 25. Thank you, Tara. 25 becomes a 5. What else? All right, 3 and 24. 24 becomes what?
8.
An 8. Okay, Brady, did you have another one you wanted to do?
4. Go with the 8.
The 4 can go with the 8 to become a 2. Anybody else see something you could do then?
22.
Okay, we could do the 22 and 2, or you could just do the 2 with the 2 we had before. Either way. So what I have left with this arrangement then was 26 times 5 times 2 times 23 times 11. Did I get them all? I think I did. So what do I have?
65,780.
Okay, so I agree. 65,000 is a lot. Is it a lot compared to the 2,500,000 I had before? Not so much. It's certainly not half, right? So it reduced it by a lot just to eliminate half the deck from my desired outcome. So let's go one further. Let's say you wanted a hand of all hearts. Okay, so what will I do to find a hand of all hearts? Okay, I'm going to pick from 13 because there's 13 hearts, right? Am I going to do a combination or permutation? Combination. They all are, right? And how many am I going to choose? 5. And we're going to expect this to decrease. Agreed? It's going to be smaller than 65,000. Okay, so what goes on top? 13 factorial. What goes on bottom? 5 factorial, 8 factorial. All right, so let's write our 13, 12, 11, 10, 9, and 8 factorial. And then my 5, 4, 3, 2, and 1. Okay, my 8 factorial goes away. Now what? Somebody suggest something, please.
4 and 3.
4 times 3 is 12, so I can multiply the 4 and the 3 to give me 12 and cancel the 12. Good. What else? Yeah, thank you, Jerry. 5 and 2 and 10. Right, 5 times 2 is 10, so I can cancel my 10. All right, so I have 13 times 11 times 9. What's that?
1287.
I mean, I know, like, if you wanted to give me $1,287, that's a lot of money, but compared to the 65,000 ways above, this is a very small number. Agreed? And if you compare this 1,287 to the 2.5 million on the previous problem on part A, it's way less. Right? Yeah. All right, let's try another one. D, a hand of all jacks. Okay, let me write down what you just said, Garrett. 4, C5, and then, did you say something, Braden? Who spoke?
I mean, it's not possible.
This is not possible. Why? Right, this is not possible because there are only 4 jacks. Now, from a numbers perspective from Garrett's, also notice that if you were to try to do this, you'd run into a problem. The problem you'd run into is that the number before the C is smaller than the number afterwards. And you'd end up with some negative somewhere, and negatives don't have a factorial notation. That is not proper notation. So you would definitely run into a problem with the numbers as well. Okay? So either perspective you come at it from, I don't care, but this is not going to happen. Okay? All right, so how about we do E then, where something can happen? E says we want a hand of the 4 jacks, and then something else with it. Oh, I never mentioned it on the one before, but does anybody know what a hand of all of one suit is called? That's a flush. So if you ever heard somebody call a flush, that's what they're talking about. So we actually found on part C getting a heart flush. And then on part D, that one can't happen, but on part E, if we had 4 jacks in a hand, do you know what that's called? That's 4 of a kind. Okay, specifically in this case, 4 jacks. All right, so we've got our 4 jacks. How are we going to do that? Garrett, can you do what you did for me last time? Close. Let's just work on our 4 jacks first. How would I get 4 jacks? Can anybody help Garrett out? How would you get 4 jacks with this combination notation? Okay, I feel like we're really struggling today. Do we need to stand up and do some jumping jacks? Okay, the number that goes before is how many there are. How many are there? There are 4. How many of them do I want to select? Okay, all I'm working on is this part right here in the box. 4, okay? I have to deal with these 2 things separately because I want my 4 jacks and then I want something else, and I don't care what that something else is. But I need to get the 4 jacks. So if I did 5C4, that would mean I'd have to pick from a certain 5 cards, and I don't have that 5th card being anything in particular. It can be anything. So I want my 4 jacks. There are 4 jacks to pick from, so I have 4C4. Then I'm going to do the other card. Okay, so I'm going to do a multiplication. This is kind of like saying I have 2 pieces, like the ones on the board. The first piece is about jacks. I need to select from just jack situation, and then the other situation can be anything. So how many cards do I have other than the 4 I already picked? 48. And how many do I need to select? 1. Okay, does everybody see this kind of as a 2-step process on this one? We're going to see others of these here in a minute. So 2-step process. We've got to figure out this piece plus this piece, and then when we put them together with multiplication, just like this on the board when we did earlier in the last section, we're going to have our answer. All right, here's the deal though. 4C4, what will that look like? In fact, let me write it underneath. 4 factorial. I'm going to write it out first because I want you to see what happens. It is 1. Yes, I agree. But I want to show you why. What goes in the denominator?
4 minus 4.
As part of it, first I'm going to put the 4 factorial. And then I'm going to have 4 minus 4, which is 0 factorial. Okay? Let's just write out the other piece too before I go back to this one. What about the 48C1? 48 factorial. 1 factorial, 47 factorial. All right, so let's talk about that. Do you remember we had a 0 factorial issue? Or not issue, but a definition, I think is how I gave it to you. What is 0 factorial? It is 1. And this is why it's going to be defined to be 1, is because as we work with permutations, we need it to be 1 to make it work. Okay? This is part of why they've defined it the way they have. And then what happens when I have 4 factorial over 4 factorial? They cancel, right? They reduce. They're the same thing. They don't reduce to nothing. They reduce to 1, correct? So this is actually the number 1 that you guys were saying. Do you understand it from the numbers, though, now? Now, it makes sense conceptually, too, right? If I want all 4 jacks and I have 4 jacks to pick from, I got to pick them all. I mean, that's only one way to do that. Okay? So I have 1 first. Now I have 48 factorial, so I'm going to write my 48 times 47 factorial over 1 times 47 factorial. And what happens? You just get, the 47 factorial is cancel, you just get 48. So how many 4-card hands, or how many 5-card hands have 4 jacks? There are 48 of them. Now, think about this. This should make sense, right? I've got all 4 jacks plus I have a king of hearts. Or I've got all 4 jacks plus I have a ace of clubs. No, that can't be right. Yeah, ace of clubs. I said it right. Ace of clubs. I've got all 4 plus something else. That something else is the only thing that's changing every time, and there's 48 different things it could change to. Does that make sense? Now let's vary it just a little bit, because this is a specific 4-card hand. It's a 4-card hand of jacks. But what if you want 4 of a kind hands? Okay, so we already said that this is called a 4 of a kind, right? This is any 4 of a kind. I don't just want jacks. I want any 4 of a kind hand. How many different options are there?
13.
There are 13 because there's 13 different cards, right? There's a 2 through a 10. There's an ace, jack, queen, and king. There are 13 different cards you could have. So if you want 13 different, you want to know 13 different 4-card hands. I mean, that's what you want. First, you have to pick which card you want to look at. So that's 13C1 because there's 13 different cards we could have as our 4-card hand. Once you've picked that card, once you've picked that it's a 7 this time, or whatever, then you have to pick all of them, correct? That is, you have to pick all 4 that exist of that kind. So that's the 4C4 that we had before. Okay, so this chooses when I get too high, it won't let me write. All right, there we go. The type of card. And then this piece chooses all 4 of them. Okay, everybody so good so far? What have I chosen so far? How many cards? Let me say it this way. How many? Say that. 4. I've chosen 4 cards. So I don't have a full hand yet, right? So what's the last piece I would do? 48. C1 for my 5th card in my hand. Now, you already found out just a moment ago on the last slide that this right here was 48, right? So I contend I don't need to do that again for you because you know how to do that piece, yeah? That one was 48 from part E. How about 13C1? What would that look like? Yeah, I'm going to write it out just for the sake of having done so. 13 factorial over 1 factorial, 12 factorial. And this would be 13 times 12 factorial for my 12 factorial to cancel, right? Still times my same 48. Don't lose him. So what does this actually become? It's 13 times 48, right? What's 13 times 48?
624.
Did I get that written right, Brittany? 624?
Yeah.
Okay. All right, so there's 624 four-of-a-kind hands. So let me ask you a question. Which is more common? Is it more common to get four-of-a-kind or more common to get a flush? A heart flush? Remember my heart flush? My heart flush was part, or diamond flush, or whatever it was heart flush on part C. Which one's more common? The flush is actually more common, isn't it? This is how they make the decisions about who wins when you guys look at all your cards, right? The one that's a less common reason to come up, the less likely to happen, is the one that wins. So if I have a four-of-a-kind and you have a flush, who wins? I do, because I had the four-of-a-kind. It's less likely to happen. I had an argument at a Thanksgiving dinner table with my brother-in-laws about this one day. Yes, he was certain he was right. Who do you think won? All right, full house. Do you know what a full house? I'm sorry, Brittany, yes.
When we do a problem like this, and we know like 13C1 equals 13
Yeah.
and 4 or whatever numbers.
You can just use that fact. Yes.
Okay, you don't have to show that it equals.
You're not going to have it happen all that frequently. Let me just say that first. But yes, if you see a 13C1, it's going to be 13. Now be careful, because then if you see a 13P1, it might be different. Okay, so be careful that you don't use one fact for the other, other operation or whatever. But yes, if you see a 13C1 and you know that's 13, you just write a 13 down. That's fine. Okay. All right, we're going to do full house. Do you know what a full house is? Two of a kind and three of a kind. So you have two of one card and three of some other card. Okay, it's not a suits thing. This is a card thing. So like fives or sevens or jacks or whatever. Okay, so full house, the first thing you have to do is you have to do kind of what we did on part F. You have to pick which card it's going to be. Okay, there's 13 different cards it could be, agreed? So first thing I have to do is I have to pick which card's going to be the three of a kind. We'll do three of a kind first. So first I do 13C1. So there's first thing I did, I picked the king. All right, I had 13 choices and I picked a king. How many kings do I need then? I need three of them. I'm doing the three of a kind first. How many do I have to pick from? 4. So what will the next piece of this look like?
4C3.
Good, 4C3. Okay, so the first value is how I'm picking, which one, all the different choices I have to pick from. The second one, I've now narrowed it down and I'm looking at kings or whatever. I've got 4 cards to pick from and I need 3. Okay, I've got my three of a kind. I'm done with that now. So moving on then. Now how many different cards do I have left to pick my two of a kind from? How many?
2.
Not 2. I need 2 of them, but how many different cards could I choose? There are 12 different styles or numbers of cards. Okay, for the sake of argument, let me just say numbers now and recognize that that may be a king. Okay, there are 12 different numbered cards. Okay, value. Let's use the word value. There's 12 different valued cards, and I need to pick one of those to be my two of a kind. But then Ethan's right. I need to pick 2 of those out of how many exist? 4. So this piece right here gets me my three of a kind, and this piece gets me my 4 of a kind. Okay, is that okay? Okay, the first number in each of those tells me I'm picking from among however many different value options I have. The second piece tells me how many I'm picking of them. All right, so Brittany noticed, and she is right, that when you do 13C1, you get 13. And what do you think happens, Brittany, when you do 12C1? It's okay. You notice that this 13C1 was 13. What happens when I do 12C1? That's 12 as well. Okay, so I'm going to write that 12 in. All right, so the pieces that I have left to do are the picking the actual card from among the ones that exist. So I've got combinations. I've got a 4 factorial on top. What goes on the bottom of this one? 3 factorial, 1 factorial. Good. All right, let's come over here. How about the 4C2? What do you have? Good. 1. I think they're 2 and 2 this time, right? Okay. 2 factorial, 2 factorial. right, excellent. So I've got 13 times 4 times 3 factorial over 3 factorial times 1 times 12 times 4 factorial, so it's 4 times 3 times 2 factorial. Keep one of mine written as 2 factorial if you'd like. These are small enough numbers. If you just change them all, it's okay too, of course. Somebody tell me something that cancels or reduces. The 3 factorials? And the, you said 2's, didn't you, Garrett? I'm sorry, and the 2 factorials. What else reduces? There's one more reducing step. Did you have a question, Sarah?
Where did that 3 come from?
Which one? This one?
Yeah.
It's 4 factorial is 4 times 3 times 2 times 1. Yeah. So I just wrote out the 4 factorial.
Okay.
Yeah, it's okay. What else reduced? I'm sorry.
2.
The 2 and the 4. So this 2 cancels with this 4, and the 4 becomes a 2. All right, so I'm not going to write them out, but I have 13 times 4 times 12 times 2 times 3. 3,724. 44. I misheard. I'm sorry. You're right. It is 44. Better? All right. So I have a full house, and you have a 4 of a kind. Who wins? The 4 of a kind, because it's less common. There's only 624 4 of a kinds. There's 3,744 full houses. Okay, so it's more common. All right, last one, and it's going to look a little funny, but it's for the purpose of us being able to just see that this works no matter what we want to call any of this stuff. You're going to have a hand, and this hand has 2 black cards, 2 diamonds, and a heart. Lucky you, you've got nothing special. Okay, we're going to see how many nothing specials there are by doing this. All right, so how do you get 2 black cards? What's that going to look like? 2 out of 26. So there's 26 to pick from, right, Brandon? And I'm going to pick 2 of them. Good. So that gives me my 2 black cards. How about those diamonds? Now what? 2 out of 13, right? I think you guys were saying those, yeah? And how do I get a heart? 1 out of 13. Okay, I see a 13C1. We've already kind of dealt with him before. The other 2 pieces, though, don't have a number 1 in their second location. So we're going to do 26 factorial over what? Good, thank you. 2 factorial, 24 factorial. How about the 13C2? 13 on top and then what? Great. 2 factorial, 11 factorial. And then we can use the fact that we now know that anytime we have a number C1, it's the same number, so that's 13. All right, so I have 26 times 25 times 24 factorial, and I can stop. I have 2 times 1, excuse me. And then I have 13 times 12 times 11 factorial over 2 times 1, again, times 11 factorial. And then I've got times 13 at the end. All right, what do you want to reduce? Give me one, Tyler. Okay, you want to do the 2 and the 26, and the 26 will become a 13. Okay, Montana, can you give me one?
24 factorial.
Awesome, 24 factorials, those got to go away too. Somebody who hasn't talked today. You guys, most of you have been talking. How about Laramie? Can you find one for me? What can I cancel?
2 and 12.
All right, 2 and 12. 12 becomes 6. All right, there's one last one to do. The 11 factorial, yeah. All right, so what do I have left? I've got a 13 and a 25. I've got another 13 and a 6. And I've got another 13. What do I have?
25.
I have bigger than 25 written down, but I may have an error. What do you have, Brittany? Okay, that's what I have written down. Does anybody else get that too? Brendan did? Okay. So this is my number of ways. So lucky you, you're one of 329,550 folks who could get this. That's why it's so special, right? Yeah. All right.